house uses photovoltaics to generate electricity from sunlight. A photovoltaic cell is a semiconductor device that contains a junction of positive and negatively charged regions called a PN junction. That individual cell, when light shines on it, generates a voltage difference, and if you connect that cell to an electrical load, you can do useful work with it. Cells are then connected together in series to form a larger module, so you can increase your voltage level by connecting many modules together, and then increase the amount of power you're capable of producing by connecting many strings together.
So one of Northhouse's main focus on energy is to maximize energy efficiency. This is done through two ways. One, through maximizing energy production and collection, and two, to minimize energy consumption. The energy production is maximized by the use of photovoltaic cells, as well as solar thermal collection to maximize the collection of solar heat. Northhouse is able to produce twice as much energy as it consumes. It produces close to 10,000 kilowatt hours per year, while it only consumes 5,000 kilowatt hours per year.
For photovoltaic energy production in the house, there are two main technologies being used. On the roof, which is our main energy producer, we're using day 4 180 watt panels, and the entire size of the array is a little bit over 8 kilowatts. That array produces over 75% of the total electricity generated by the house. The other technology is a product from Shunko, which is a custom designed building integrated photovoltaic product. So we've got that on the south, east, and west sides of the building. The east and west have about a little less than 2 kilowatts of PV, and the south has a little over 1 kilowatt of PV. With solar power, we can quote what the maximum power production is, but if you want to talk about how much energy is produced, it really depends on how much sun you're experiencing.
So in order to maximize our solar collection, we've actually placed solar panels on both horizontal surfaces as well as vertical surfaces. The horizontal surfaces make use of the high angle sun that we normally experience during the summer, whereas the vertical faces are maximizing energy collection during low angle suns during the winter, and in cases of east and west facing facades during the day when the sun is rising and when the sun is setting. Rather than actually building a entire tiltable and adjustable solar array, we actually have orientated the house to collect as much sun as possible.
So one interesting thing about our house is with regard to the solar thermal collectors we're using. It's quite unconventional to use solar collectors that are at horizontal orientation. Of course, the sun is very rarely directly above us. It's often lower in the sky, so we have some kind of solar angle here. But one good thing about the Vitasol panels we're using is that each tube is actually tiltable. We can twist it. I actually have it at about 20 degree slope. So even though the array is horizontal, it's actually getting up to 20 degrees without getting too much shading. Yeah, it's Vitasol 200T.
The average Canadian household using 1 kilowatt of power continuously. That works out to approximately 25 kilowatt hours per day, 750 kilowatt hours per month, or 9,000 kilowatt hours per year. If you look at our anticipated energy production from the Northhouse, we're producing 870 kilowatt hours per month and over 10,000 kilowatt hours per year. So this house, which is much more efficient than your average Canadian household, is producing more electrical energy than the average Canadian household would require. The electricity produced by the photovoltaic arrays is in a format known as direct current. In order to make it into a useful format for the people in the house, you need an inverter to convert from DC to AC, or alternating current. You may all have seen a simple inverter like this that you plug into your car. These work using batteries as their generation source. Our house, there are no batteries, so any electricity that is generated can be used by the house, and any surplus is actually delivered to the electrical grid. And if we're not producing enough electricity, for instance at night, then we'll actually take electricity from the electrical